Yes.
Arg?
Yes, again.
What are we doing?
We're here again with a AI Tinkers inaugural meeting special.
Really?
So Michelangelo, demo number 1, for our very first meeting, December 2024.
Okay.
He was going through a very complex topic, covariate tagging, semantic tags.
None of that makes sense to me.
He will go through it.
Okay.
And then I was demo number 2 for group divination for 8-bit Oracle. So that's when we met. William was there. So this is actually sort of a
inaugural,
a reunion of that very first meeting, a partial one, because Jeremy, William, Michelangelo, and myself, that's where we met at that North Point Grill. Yes.
Wow.
So it was a spectacular event.
You have been on and on about, like, we have to get Michelangelo.
For a long time. He also introduced me to a spectacular pasta place in Tycoon. We had a wonderful dinner.
Okay.
So very vivid memories whenever I'm with Michelangelo. I feel like he is sort of like a virtuoso or a special human. So we're very fortunate to have him, and that's Michelangelo. Yes.
Wow.
All right.
Okay. Go ahead. Buonasera.
Buonasera.
Come stai?
Bene, grazie.
Bene.
Your Italian is perfect.
Oh, thank you.
Compliments.
Wow, that's I spent a little bit of time in Torino.
Oh, that's very nice food, but cannot compare to Florence or Siena.
Of course. I actually went to Florence a couple of times.
That's
very nice place, yeah.
So thank you for hosting me tonight.
Well, you come highly, highly recommended. Everyone was like, oh, Michelangelo? Oh. So tell me, what was it? Semantic tagging?
So at the beginning, when I met Augustine, I was working. So just to give you a background on myself, my specialty is search and retrieval algorithms. So when I started studying machine learning around COVID time, 2020, then later on I realized that there was a space where not only things were interesting, but there was a lot of things that still had to be discovered. That space essentially was search. That is something which has become extremely important, but at the same time, people are still discovering new things. And what
do you mean? Like people do, like we search every day, don't we?
Exactly, but there is a giant problem in search is that when you have this technology, large language model, they cannot help up to a certain point. So this is called essentially. So we are shifting the topic quite rapidly, but we go back to the previous version, like it. So essentially, it is called RAG. When you search for information, you have two components. The first one is querying the database. So basically retrieving information in the traditional format. And then once this information is retrieved, you can pass it down to a large language model. And so it's hugely problematic because no matter how much progress we do on the frontier of AI in terms of reasoning and large language model, before we have to use the traditional models. So, and if the traditional models are dumb or not as smart, then we're blocked with that, trash in, trash out. And this is the biggest problem. And then I realized over time that even with AI doing incredible progress on the reasoning front, we are still stuck on the maximum level of complexity that those small traditional models can sustain. And this is a problem now that we are facing nowadays.
I'm trying to see if layman can understand this, right?
Well, so think about an Excel file. When you imagine you have an Excel file of data, of resumes, okay, and you want to select the 5 resumes that are good candidates for you. Before starting, you have 1 million of them, let's say, and before passing it to a large language model, you have to work on that million. If you have Excel file, what do? You can press Ctrl F, you can sort it, you can filter by tags. All those methods that you know how to use, those are the traditional methods. And that is the problem we are facing right now. We're not even touching the LLM yet. We have to deal with an Excel file, with a table, with a format that we know how to filter, essentially.
And is it so you say when the traditional way of searching, when you can't do a lot of complexity, right? You can't do like 20 search at the same time.
Or
Is that-
potentially you can, but there are many complications. For example, searching through text without using a reasoning model is complex because it's not that you have availability of question answering. So there are basically tricks that there are, for example, something called semantic search. We try to use as much not computing power, but the most capable algorithms, let's say, to filter to search through this data, but they do not perform as well as we're used to with LLM. And so, for example, even if you search through text and you do a regular search, and then you compare the results, you see that most of it are wrong. Most of them are wrong. And this
Is that why when I use my phone's note when I want to search for something, I can't find them, even though
well, also perhaps because search is actually complex. So, when you make a search, first of all, you have to index the data. You have to organize the data in a way the computer can retrieve it.
Because that was how for a while that keywords is very important when you tag keywords. And I think for most people online that they would know is like when you have to hashtag.
The SEO.
Yeah.
Well, because especially, basically that was the traditional way of searching. Right now, not right now, but up to 10 years ago, they extended that search with the semantic search. So keywords, let's say, they are not searching their coded keyword, like Control F. But for example, if you search for lamp, and light, for example, they are very similar and they are included in the search, for example. They are interchangeable. They use the whole text. There is a much more complexity on top of it, but those are the most advanced model. The main problem, I would say, that despite those models having improved over time, there hasn't been something new in a very, very long time, basically 10 years. There almost been no improvements in how we perform the search, no new approaches on top of that.
So search is actually quite bad. And then the result that's getting retrieved.
Exactly. That's exactly it. So we are dependent, let's say, on models that are traditional, but also quite dumb compared to what we are used to right now.
So that was what you were working on? Exactly.
That was because I noticed that and I said, okay, well, when those models came out, we said, we can connect it to a database. And, I lighten up. I said, how? And then I saw, well, you cannot connect it to a database. You're filtering out a huge amount of information and only feeding the top. So that is good, but it doesn't solve the problem that we always had right now. And it will not solve it because you cannot put an entire data set into a machine learning algorithm. Well, what you can do eventually is essentially train it, but those models are not used to be trained on raw data. You cannot just put a data set and put them in
memory. They need to be labeled, right, in text.
Not only, they need to, for example, the way they're trained is through a conversation. And at the same time, they do not retrieve, when you retrieve data, you have to be extremely precise. Even if you are able to create conversation on top of all their data, they're not going to reference the exact row or number that you need. And this assuming that the data doesn't change. So the way those models are built are not compatible with this mathematical problem that we're facing. And so my interest at the end was given that we cannot make search smarter using those frontier methods, maybe other mathematical way, algorithmic ways that we just make it smart, make the traditional algorithm smarter. So my specialty over time was not to focus on the large language model themselves, because for example you have experts like William or Jeremy who they're respectively known for their knowledge on the algorithms and then infrastructure. My job is also part working with LLM, but my specialty, what I really want to do is to make the traditional search model work better. So it's a world which is impermeable to LLM as of now.
So the search has to catch up, otherwise, no matter how the LLM, how powerful it you are going to get some garbage.
Exactly. And so what those models have been relying on is basically, so they created new architecture, better models, of course, which is always nice. The latest one, I think, was Gina V4, published a few days ago. But those are essentially hitting a wall, like every other model.
Can we say that, like, it's almost like the analogy of building a building? Like, like the traditional search is actually, in some sense, is the foundation.
We could say that, yes.
And then, the LLM is on top. That's actually the building. You can see that the superficial side of it. But if the foundation is shaky,
exactly, then nothing good comes out of it. Well, in our terms, we say we use a different analogy: trash in, trash out,
or GIGL, garbage in, garbage
exactly,
out.
garbage in, garbage out. And so, that was my interest. And at the beginning, what I mostly was working on, actually was art. That was how I started, because the beauty of search, it's that we have different kinds of data, and each one represents a completely different problem. So with LLM, the easy part is that you sort of have one problem to fix all. It's a sort of silver bullet. So of course there are different variations, like the LLM that can code, the one that can reason. But overall, if you have, for example, some text, you can pretty much feed it to every LLM or on every size, and they can answer your question on top of it. That's the beauty of it. You do not have to engineer which kind of LLM is compatible with your text, unless you want to obtain incredible results. In that case, it's something different. For search, it's different. Every single kind of search you have, you need a completely different algorithm. So you cannot, because for example, if I give you an example, like if you say articles, articles, you have textual data, which is already a problematic thing to search. But if you have art, especially artwork are a combination of both text and images, and they do not fit together. So, for example, if you give me a painting of a tiger, that painting could be called Silence, or Blue Ocean, which has nothing to do with the actual semantics. So there is a huge misproportion, or dissimilarity, we could say, between the semantics of the painting and the semantics of the title. And originally, that was one of the original problems that I focused on. And then overall, I abstracted it, the solution, into different fields, and I saw that the more basically you expand, the more you have kind of data that require a completely different approach. If you search for invoices, you need algorithms that specifically looked at key value pairs. If you looked at regular text or articles, you need the TF-IDF based algorithm, etc., etc. And so you have a huge expanding category of that to make search basically work.
Just the art piece already seems very interesting, because like for Hong Kong, now Hong Kong is trying to work towards being an international art hub.
Yes, there was the base...
the Art Basel.
Art Basel, which every year is huge here in Hong Kong.
Yeah, and I'm sure that right now a lot of galleries are having quite a lot of difficulties just to catalog their works and do searches, right?
Well, also one of the big problem in this regard is also ambiguity. And like this is, we are talking from it's called epistemological perspective. What we're talking about is when you classify knowledge in general, you have to choose basically like a hierarchical structure. You cannot, it's like if you take all the artwork, there are many ways you can classify, you can come up with a tree. So, for example, you can classify them by author's name, and so you have one tree of author name. But you can also, this algorithm is called group by, essentially. But you can also decide to group them by period, which is smarter, or you can even group them by color ranges. And so there isn't a proper way to do something.
Or by style, like Flauvism,
and exactly,
Expressionism.
and any feature, you basically can classify up to any interpretable or discrete feature you want. And so this creates a problem also from a classification perspective.
Yeah, because there's something that sometimes something can be either or both at the same time.
Exactly. So basically, when you have more complex hierarchies, something can belong to multiple parts of the hierarchy at the same time. Our brain is also, I don't think our brain is set to follow something like this. So probably the proper structure is to have one gigantic tree which can encompass an entire knowledge base.
When we're talking about tree, it's like, most people very often they would come across like trees, probably like family when they go into genealogy.
Exactly.
That they will see that who is the grandparents, who is the father and children's, and knowledge comes in like this as well.
Exactly. I think at least that's a proper way to classify it. I mean, there has been many approaches. For example, I think what it was Oblivion, which is it's a software. They use graph-based nodes in order to classify some of them. And so that could be a different approach. I think, personally, I think our brain does not transcend, let's say, cannot go further than trees themselves, because we are used to classify things in categories. So using a tree as much as, a graph, for example, as much as beautiful it may look, but then it does not, it's out of our sphere of comprehension.
Do you think it's a generational thing?
No, I think it's brain nested. It's
the way that our brain was formed and functioned.
Yeah, I think if you look, for example, at animals, one of the huge difference between the animal brain, the human brain, is that the human brain can abstract, the animal cannot. Or that is correlated with IQ. The more IQ you have and cognitive abilities, the more you can abstract things. Which means, for example, you can put things under the same category. So
well, the crow seems to do quite well.
Perhaps they are considered quite smart in the general domain. But for example, if you think, this is very interesting, if you think about autistic people, I would say their main feature is that they are unable to classify things. They're unable to put things in the same category. So, for example, if you give an autistic person, high on the spectrum, of course, 2 spoons, they cannot understand that those are 2 spoons. Is object A or spoon 1 or spoon 2? So, and that is, I think, the biggest difference.
So they cannot lump together those spoons.
Exactly. They cannot put the spoons in the category. Instead, what humans do, they create an abstract category of all things. It's like danger. Animal, for what I understand, also if you see Jordan Peterson lectures, he talk about this in detail. But for example, if they don't have a concept of generalized danger. Everything is danger, like every
different
object.
Type of danger.
Exactly, but there isn't a concept of one danger, and humanity can do that.
And also that has something to do with culture as well. I think the Chinese are very good, at abstract, thinking, and
I'm sure there are probably contamination from culture. Culture affects us in a different way. So definitely it has to do with it. But then on the presupposition is that humans can actually do that, compared, for example, to animals who actually can't. And so I think, coming back to what we were saying before, I think the way also we're used to classify knowledge, but is perhaps by using trees, by using categories. And also that's why abstracting things in a graph, though it also makes sense because there is the possibility of doing that, but I don't think it's compatible when we scale knowledge itself. When we have a huge amount of knowledge, like we need to eventually in our life remember thousands of things, especially in our job, we cannot properly put that into a graph structure. Yes. We need to put them in a tree, and the tree has to be set enough so that objects do not get shared into different categories. They have their own place in the tree, which is very restrictive because, of course, objects can be shared into different categories.
Because if we are very in this very restricted labeling, it doesn't allow sometimes people have sometimes some object has share category, and then there's no room for ambiguity.
Exactly. So sometimes it's better to choose the best structure rather than perhaps if that is as you were describing, that is the optimal structure there is, but perhaps it's better to choose the best structure of the role. What best work for us?
For instance, let's go back to the example of art. When you have an artist like Picasso,
right?
Like if we're talking about style, which style does he belongs to? You know, he's in Cubism, he's in he's in Expressionism.
He's shared in different parts, and so that is the difficulty.
And that's going to be a tree problem going on with classifying Picasso.
Right. So you basically have to make the tree in a way that is basically more convenient rather than just classifying it by periods. And so there are many, then it becomes more and more complex on how you build on top of that. But that definitely, that is essentially creating taxonomies, which is an ontological problem on the creation of taxonomies.
That the ontological problem is also then we become very philosophical about this thing.
So exactly, we get into rabbit hole, but basically, for what I understand, the ontology was they understand the overall knowledge, and the way ontologists right now they basically work on problems is to create not trees but basically graph that represent every single feature about objects, which I have very little experience in this. I'm more on the computational semantic side. So I'm more restrictive.
How did you start to get into AI? What was your background?
My background was in finance.
Okay.
Actually, my degree was called international business in Tankam University from Taipei. But then, basically, from international business, I shifted into quantitative finance because I realized that it was something I had talent for. And then COVID happened, and as you can imagine, I was stuck in Italy, which wasn't so bad being stuck in Italy.
In Florence.
Close to Florence, yes. So I had a small house there.
I don't think that many people would mind to be stuck in that part.
I didn't mind for quite a long time, to be honest. The food was more than I could have hoped for.
Yeah.
So, but of course, during COVID, nobody was hiring, especially people did not have, at the beginning, remote policies. And so, I finished graduating around that time, and I said, okay, well, I'm home. What do I do while I'm home? I have to keep specializing. But it's very difficult to study finance on your own, but computer science is completely different. And so I'm self-taught, I started going into the direction of computer science.
But you didn't have a background in computer science before?
No, never.
No coding experience?
No. Well, compared, because at the time also it was challenging compared to now because you didn't have LLM. So whenever you had a problem, you had to Google the problem. You had to do the RAG yourself without the second part, and you had to identify the top article and manually understand what's the problem, or go around in forums. So, but compared to many other subjects, computer science in general is something that is much easier to learn, because I would say that. Compare, for example, if you study art, okay, well, it's available. You have an availability of everything with the computer, but you cannot just make things up. In the sense, you need an expert to tell you if you're right or wrong. So even if you want to become a philosopher or a lawyer, you still need an expert that basically is in front of you and tells you if things are correct or not. I would not possibly think of becoming a self-taught lawyer. Number one, I'm not talented, but I can come up with everything. I can come up with my own sentences, and then an expert can say, "No, Michelangiolo, you are wrong about this. How do you learn it?" Computer science is different because you can validate your output, so you can actually see by yourself if your code works or not, which it's a very powerful way of moving forward. And then at the same time, of course, at the beginning, that is the first few months, that is all there is to it, like working code. But
so
then,
you were learning Python?
Exactly.
Yeah.
Python, I think you have a choice, people have a choice between Java, C++, Python, or JavaScript.
Well, C++ is another beast. No?
Exactly. But at the same time, for example, it's like building video games. You know, you can actually see if things are working or not. Then, of course, there are other. When you study engineering, when you become an engineer, there are more complex components, which is then you have to introduce best practices. So, for example, your code works, but you have put an API key in the wrong place. That is quite serious. But at the same time, you can start optimizing. So, of course, the more you expand, the more you know how every little integrate detail. But then at the same time, there is always the chance that you can validate your own answer. You can see if what you're working on is not only theoretical, it actually works or not, and you have the proof.
And it's not objective. Going,
exactly. Well, computer science is definitely not objective. You can debate about something, but if your algorithm throws an error, that is not.
It's not like your code is written beautifully.
Exactly. The God of Python, the God Python is right on that.
No.
Exactly.
Yes. Okay. So that's how you started.
Exactly, and then after that, basically, after 1 year, I was writing a lot of articles. I think I wrote more than 100 technical articles in 1 year. They're not peer-reviewed articles in that sense, but they were on Medium. I'm quite proficient writer on Medium. And then after that, I got into EY. And then, I was able to get my,
in Italy.
That was in Italy, yes. EY Milan, and that was a good exposure to corporate on basically how they do things in a most advanced way, how to cooperate in a team. Those things you need to actually be there and learn it.
Did you work on retail projects at EY? Is that why your tag demo was?
No, actually, I worked also for A.S. Watson later on, and that was a retail company. Of course, as you can imagine, I'm not allowed to discuss which kind of project I worked on, but yeah. But retail is quite an interest. Another, as we said before, there was another problem because compared to documents, you have long text. In retail, you have very short text. So you need to use another set of algorithms because the search in retail is completely different from the documents, for example.
Well,
yeah, I mean, it took me a while to sort of catch up to what he was doing with tags. So we sort of take tags for granted. We see them all over the place. But the assignment of the tag and the derivation of the tag, there can be a lot of complexity and logic in there. I think that's how you are sort of able to shape your search.
Sorry, tag, you mean like?
Just the distillation of that object or that document.
So, for example, if let's say one example is Steam. Steam is a platform where you can buy 1,000 video games. All the data is tagged. And so if you go on Steam, for example, you can see which kind of games you play. For example, these video games about zombie, these video games about FPS, first-person shooter, and everything is tagged. And I think that actually led me to an idea is, okay.
For layman is probably called keywords.
I had labels as well.
So the difference is the keyword is part of what you're searching on. But a tag has some relation to what it is. It might not actually exist in so a zombie.
For example, if you have like a description, okay, perhaps the keyword itself is exactly matching a word in the description is in there. A tag instead is basically saying, okay, how can I label this kind of
category?
Document? Exactly, it's a category.
That's and so style of a tag.
Yeah, and so basically, my idea was, okay, what if instead of, because text, the main problem of text is that it contains noise. What does it mean? When you take text and you encode it, you try to search on it using semantic search. If you have areas of the text that have nothing to do with what you're searching, or basically deviate, then your entire vector is compromised. And of course,
words. For example.
And even now there are smarter model, but that weights the vector in a different way. And so my idea was, what if instead, I try to remove all the noise? How do I do that? Either I edit text, which is an impossible task at scale, or there is a possible way to use tags in order to search things.
And also, does some of the noise come from people just do typo wrong?
No. Well, that doesn't affect a lot. But for example, one of the search where this becomes most useful is resumes. Resume search is one of the toughest search there is because here we go, like another type of data. We mentioned, for example, article, we mentioned retail, we mentioned art, and this is, we mentioned invoices, now we mention resumes. All of them are completely different kinds of data. Resumes, they have a problem because you have a variance within the semantic distribution of the data. What does that mean? Is that within one resume, you have several different concepts. You have education, you have work experience, you have skills, you have even, for example, the introduction letter. So
and sometimes people might call a same university or same college with a different name.
Exactly, and that is the problem, is that you have, number one, the data is quite long, but at the same time, you talk about different things within the data. So if you have an article, that's the thing. Most of the time, the article focuses on one thing or one topic. Maybe not, but you also have different headings, so quite organized. When you have a resume, you talk about 5, 6 different things, different together. Usually the vector goes crazy. So one of my ideas is, what if instead I search not using a query, so not using a regular text, but I search using different tags. So a combination of tags that I average together in the vector space, and then I weight them using differently. So in semantic search, one of the biggest problems is that you can only search using one piece of text. Maybe very long, but one piece of text. And you cannot apply, for example, any weight. So an example is, let's say that you are searching for a salesman who works in tech. That already makes all the current model go crazy.
Oh, really?
Something is simple, but what companies do is that they manually have to label each resume to say, as we said, as categories, this is a salesman, this is an engineer, this works in marketing, and they do that iteratively. They still do it right now, even with LLMs. But
like you're telling us that now, like we thought, like from the public, thinking that we're moving so far ahead. We like computer can do so many things. It can actually like eliminate all this boring tasks. There's still someone that has to go there to each resume and tag all this area.
Many big companies do that. Number one, because of compliance. So we talked also with the previous speaker. Compliance is a big issue. Cost as well. Though it costs more to basically pay a person to do that. But at the end, to create a pipeline that does it automatically and make sure you do it correctly, at the end is more time consuming than actually maintaining the old system. And so, and also...
The more I talk to you guys, the more I think job security is there.
Job security is there, so yeah, don't worry about it. But how to say? Well, yeah, so basically what people do is this. They use still right now, people use conventional filters. So if you want a salesman work in tech, you filter for all the salesmen that people have, the category of salesmen, and among them you sort them, for example, by understanding which one has more tech experience. And that is a way to do it. My way was, what if instead I apply, I search for all the salesmen, I only use semantics. I don't use any pre-made categories. I search for the sales component, but then I give it a different weight. So I give it, for example, 70% or 0.7. We don't use percentage here.
But how do you come up with that weight? Is it like you determined it?
Well, at the beginning it's arbitrary because it has to be something also that, but also I'm working, for example, just experimental to algorithm to automatically detect the weight. The weight.
But this means that like this weight distribution really comes with experience and
no, not necessarily, because the models basically is more mathematical. So for example, let's say the same query, salesman and work in tech. If I look at the top resumes, for example, let's say semantically speaking, the way those models are built, computer science keyword has more importance than the other. Then, for example, those resumes can be, I look at the keyword, only 2 of them have out of 10 have relevant sales experience. So my keyword has not even been found, though I put sales. If you put like sufficient weight, you can build a mathematical model that optimizes, which means like when you make a search, it kinds of converge into a point where you see that the number of sales keywords, or basically the importance, it's increasing up to a certain point, up to a certain convergence point. So there are mathematical ways that you can work on semantics to make that happen.
But like you said before, that in semantics sometimes like you have lamp and then you have like light, and then, and people might not necessarily use the same words like cells.
Well, in that case, semantics model basically solve the problem. Okay. Because in semantics model, you can use any replacement, and as long as they are similar, it's like using, for example, a hot dog and hamburger, which to me they are completely different. But anyway, if you use that compared to clouds, the semantic model basically places them in the same. The semantic model does is it maps the meaning of words into a mathematical space. And so you have a universe, we could say, imagine a stars or just mapped out in an n-dimensional space. It's called it. We could simplify to 3D, just we can visualize it. In the same location of space, there are words or there are concepts that mean similar things. And actually, it's a pretty easy thing to do.
But that's similar, like to how we used to use beside dictionary, there's a thing called thesaurus, right? That help you find similar words.
Well, yes. Well, if it's semantic, if semantic space, definitely yes. And so those models actually are very old. Just right now, we are able to encode information in a much more efficient way. And so essentially, my idea at the beginning was to find what is the limitation of semantic search. You can only have one variation. It only goes in one direction. You cannot really change it. So if your query works, that is good. If your query doesn't work, you are kind of screwed. Because what do you do after if the semantic search fails? And so my idea was, what if instead of applying different weights, every single time you change weight, you have completely different results that can align better with your query? And that was, for example, I call it covariate search. I might rethink the name, who knows? But that was basically covariate search.
Covariate search.
But and then on top of that, I came out with I'm trying to publish a paper right now. On top of it, if I can publish it, on how to label data. Because also one big problem that we have right now is we have no way to efficiently label data. We can say, what I mean by efficiently, we cannot do it at scale. We have to spend a fortune. There is no algorithm that can label data in a very fast way.
So you don't want to use an LLM. You want to use something more algorithmic.
Exactly. I want to use specifically raw embeddings. So my goal is to outperform zero shots.
So please explain. Like anyone can help. No.
Well, basically, what happens is that
embeddings, but not row embeddings.
Okay. So, well, embedding. No, well, I call it raw embeddings, the sense that raw to emphasize basically that I do not want to use a zero-shot model. Okay. So basically, in layman terms, the way we label data as of now, basically there are, I would say, two big ways. The first one is to use neural networks. So you plug it in a neural network. Those neural networks perform something called multi-label classification. So essentially, you have a text and you have many choices of the text. And you can say, for example, so you have a text about animals, and then you say, okay, giraffe, tiger, cow, whatever. Or you can have an article and you put all the classes that you want, a pool of classes, and then the model decides which class, the percentage to assign. They say, this article about finance. This article is about, so you put 10 classes, it gives a percentage to all the classes you've chosen. The problem of this model here is that it's unbelievably expensive in terms of computing power. So it's unbelievably slow. To tag like one article, to describe, like to label one article takes 7 seconds, which in our world is not scalable. Because in order to classify 50,000, you need 350,000 seconds, which is basically 4 days to classify a data set. We cannot do that. The other option is to use large language model. And yet it's beautiful, but that is not proper. They're not algorithms. They're not used for scale. Those can be accurate, but then if you have to process 50,000 pieces of text, it's going to cost you. Perhaps not a lot right now, but it's not a proper way to do things. So another component of my research is how to label data in a very, very efficient way without using any of those solutions.
And you're going to open source that when you finish.
Everything I do is open source.
Yeah.
Wow.
So it's I'm a fan like Jeremy. He's more a fan of open way. I'm more a fan of open source. But definitely all the things that I do are open source. I release the algorithm and the description on how to obtain it.
On GitHub? Or?
Yeah, both on GitHub and Medium. Now I'm trying to use Arxiv to publish. Let's say in more academic ways, not peer reviewed, but still
I'm
more.
down. I'll contribute my brain power somehow. I hope to on this. So I would love to try to help.
So we'll try to put like your descriptions on your like we're going to put your information on descriptions as well,
much appreciated.
And Hong Kong OpenAI Hong Kong AI podcast. Yeah.
But if OpenAI wants to sponsor us,
yes,
we can.
They should.
We'll change the name.
We can. We are very enterprising. Yes. So that sounds really good.
No, it's spectacular. It took me like months to sort of understand what he was getting at in that very first demo, but now I'm using it in my project.
My objective essentially was this: given that companies use weights, they need a lot of time, effort to classify, to extract the data, and extract those tags, to categorize, to label things, and then manually filter them out. What if there is one go solution, an end-to-end solution that can simplify the process? No more tagging. So you can search the data by extracting automatically all the tags in a very scalable way, and then you weight it. And if you weight it, you can have better results. At least, there are some domains where this works, other, for example, in retail, that this cannot be applied. I mean, the label seems very nice, but then you cannot use this weighted search on very, very simple kind of documents.
So the way he describes weighting sort of reminds me of a tactic that William taught me, which was embedding the question as part of and tying it to the objects that you're searching against, right? It's sort of like you're sort of like tuning it in the weights in a way to sort of match the queries to the results that you want to get. Is that sort of right?
So sorry, in this sense is basically rather than with semantic search, the problem is that you cannot properly weight something. If you have like a long query and then you require one simple thing, then that simple thing, for example, that it gets ignored because it's within the sea of information.
Yeah, I see it. I see William nodding behind the camera.
Yeah, and so basically, everything else. For example, if you want to focus on something, everything else is called noise. And the problem is that when you have a piece of text, you cannot, in the traditional algorithm, you cannot just simply extract and reprocess the text. You need an LLM for that, which basically is against the principle of scalability. You don't use LLM for scalability. And so by the traditional approach, you have a lot of problems. You cannot even extract, for example, simply with algorithms, even extracting common words, it's even problematic.
Really?
Yeah, because you need to parse it through in the library we call NLTK or Spacie or TextBlob, but you need to parse it to traditional algorithm for extraction. And those we could say, are extremely dumb compared to an LLM.
Yes.
And so even extracting, for example, phrases that go together, like state of the art. State of the art, for example, it's not one keyword. Like there are 4 words stuck together. State of the art, 4 words. But even to put them, all 4 words, and extract them together, that is very difficult to do.
Because they're used to words being one words.
Exactly, and so with the way there isn't a proper, like for example, when you work, this is called working on strings, just text.
Yeah.
You need a very traditional machine learning model. You can use an LLM, but we said we don't want to use it. You can use a traditional learning model which has been trained to extract this kind of data. But at the same time, those models are very simple and unreliable. And so, for example, state of the art, most of the time I tried, is not even captured.
So, and also there might be other problems with other languages as well, right?
As well, yeah. For example, like I am not
because in Chinese, right? You have like sometimes some words is one characters.
Right.
Sometimes certain words are two characters.
Yeah, well, you need specialized model for that, and also those models can be extremely unreliable. Plus, at the beginning, those models they all rely, as Jeremy said, on basically human labeled data. At the beginning of for example, machine learning, we had huge data set of data which is being grammatically labeled, like hundreds of thousands of documents manually labeled to understand the grammar and to teach those traditional models how to interpret grammar.
And in that sense, that probably even a bit of a problem because most of the model probably was built with English, and then now that
that causes definitely a problem. For example, if you look at the LLMs, they perform way better in English than other languages like Italian, which compared to the English literature used on LLM is not so big.
Yeah.
And so, for example, even document processing in Italian is completely different. Like the output is completely different from one in English.
Yeah, because there's probably not that much work being done on Italian.
Exactly. The size in this case, it has a huge effect.
How is this related to comic books? I wanted to know.
Oh, yes. I almost forgot. Thank you all. So, how did, know that you also start drawing a comic book?
So, originally, the plan was, so I used my idea. I haven't open sourced it. That's the only thing I haven't open sourced. Who knows? But I might put it. Out. I can share with you. How about I share with you some of very cool images?
Yes, that would be good. Yeah.
We need to link to something. So whatever you want to share, we'll link to it in the description.
So my idea at the beginning was starting something like a fun project, because in my family, unfortunately, I have two curses. Like half of my family are one of the branches of my family are engineers. The other one are artists. And so basically I got both. And so sometimes I have the engineer instinct to keep creating things. Other times I have an artistic instinct.
You're from Florence after all.
And I'm called Michelangiolo for one specific reason. But essentially the problem, there is another problem. As much as I would like, I do not know how to draw. So at the beginning, but I can write good text, I think. I can write good stories. And so one time I was so bored one day and I said, okay, I created a great story. I like Lovecraft style. So I write in the style of Lovecraft if I can.
Wow.
I love it.
So very convoluted, very ancient. And so I tried to basically use Midjourney to represent it as a novel. And actually, the result was quite good. I arrived at 10 pages. But as you can imagine, when you start creating something, you don't want to stop. And so then I write 20 pages. Then I said 40. Okay, now it's done. My story has been fully done. What do I do with it? I can create other separate stories. But no, I'm sorry. That is too beautiful. And then I continued. Then I continued day after day. And after 6 months, because I had to arrive to 200 pages in a rush to see how it was going, I said, okay, what kind of story am I making out of this? And then I arrived 460 pages, properly done with Figma, with the pagination. You would not believe how many iterations of image you require to create, to put a consistency, to obtain the consistency of the character. Because the biggest problem is with those models is consistency. And you cannot have a character basically be the same over many iterations. You can reference to it, but it's always a mess. But my idea was, actually, there was a pretty good intuition on if you use the same query, like 100 times, 10 to 15%, and the query is simple, 10-15% of the objects of that iteration, of that 100 generation of images are going to be the same. So if you want
mean the image?
Exactly. If you want the same character, but with sufficient iteration, the LLM does not have sufficient variance, and it generates almost the exact same character over time.
So if I want to, let's say, a famous comic book character like Tintin.
Exactly. In that case, for example, if you describe it, there is sufficient data for the LLM to generate a consistent character. If instead you describe, let's say, a knight, okay, every single time you have a different knight, but at least with the face, though the new model like Midjourney 7 came out after I finished the comic, that was 3 days after. That was quite a disappointment. But no, I'm glad he did it with the Midjourney 6, actually the model I used, and you can obtain basically the same character face over some period of time. Because the LLM does not just create a completely new face. And so, for example, like one of the characters that it was blonde, I used the query like blonde, beautiful man. With the same query, 15% of the generation are always the same character. The dress in the clothing is a bit different. That is the only problem, but it's kind of been fixed with the new generation. But that is sufficient to generate. If I say blonde, beautiful man in green suits, it should give me like at least some like recognizable. If you make 100 generation, a percentage of the generation you will basically get the same character in different poses, in different. You can basically rent with it, but that I would say is the secret to consistency.
Interesting. Like a probabilistic consistency.
Exactly, and so the actual then of course you do a lot of Photoshops. Photoshop, when you merge Photoshop and Figma, could have a very good result together.
Now, I'm very curious. 460-page story. I'm always curious about the creative process because when you're writing the story, do you not know where or how it ends, or you're just experiencing?
No, actually, you have to know. But the thing about compared to a book, that's what I experienced. That was just purely like there weren't any guidelines to follow, unfortunately. I'm a huge fan of guidelines, as you can imagine, but basically I had to come up with a system how to put it together. And at the beginning, for example, I was creating everything is organized in tranches of 20 pages each. So basically a chapter has 20 pages. At the beginning, basically I was just creating on how I was creating without a due process, just like page by page. But then I realized to make things proper, I had to plan essentially the story. So basically you see the high resolution, you plan what's going on chapter by chapter, then you zoom in and you look at the story and say, okay, what's going to happen in those 20 pages? You go from point A, point B, and then you put the different actions within. And then you have to understand which image goes into from here to here. Because, for example, going from 0 to 20 is difficult. But then you say, okay, there are 6 points that I want to happen in this chapter. Okay, the first 3 pages, they focus on this specific action. Okay, I need in 3 pages to go from A to B, and I have to put, for example, a limit of 6 images with a different configuration per page. And so from there, you understand which image you want to draw. You come up with a 20-page outline, and then you start generating. But that is not always so easy because, for example, one of the features of my book that is it's quite violent. A lot of blood. There is a chapter that is all blood. And Midjourney.
Generate violent pictures.
Yeah, exactly.
So that's where Photoshop come in?
A combination of Photoshop and a lot of patience. But for example, there was one chapter that was very bloody, 30 pages, just because it was an extra chapter.
Like a giant spear going through the head.
Something like this. Not to the head, but and with Midjourney, I was able to generate just a stream of blood without getting banned, without getting even. But it took a long. It took a long time because I remember to make. There was always a climax within a story to basically reach the most important 10 pages. It took me 3 days. I was going 3 pages a day with, I went to 200 generations.
I almost think that there should be a documentary of him just, filming you generating
I will say it was quite fun to make it. And plus, but I don't use, if I can do it by myself, I don't use AI. So the text is being written by me, for example. but because I enjoy that composition.
The
exactly.
Process, yes.
Yeah. But then, of course, then then I have to say, it came out like a pretty good.
Did you write just not really thinking how it's going to generate afterwards? You just write whatever you want to write as a text, and then you think about how to generate. Yeah.
Exactly. But I have to plan it. But the problem is when you actually hit a roadblock, because for example, the Midjourney, there are two models in Midjourney. One is Midjourney, which is basically a general model, which I do not know which is the most advanced version. I'm stuck at 6.1. Because I never use it. And then there is another one called Midjourney, which is specialized to draw anime, which comes very in handy when you have to make comic books, for example.
Because the anime style and the American comic book style is different.
Yes, but how to say, in my case, well, it was not like a movie anime, but it's very close to hand-drawn things.
Manga, right?
Yeah, exactly.
Yeah.
So like it's very close to that style rather than the one that is like perfectly drawn. So, and definitely not realistic. You don't want it to be realistic. The problem also of comic book that you see right now in the quality, that the average quality of AI-generated comic book is very, very bad. If you look online, mostly because, number one, there is a lack of consistency. And also because many people used model before a stable diffusion, which is definitely not one you want to use. But then, like, there is always a way to do that if you're creative enough. That was a creative experience. I know many comic book aficionados will hate me for that, but it was worth. One of my the goal of my job is just to keep experiments, to push it at the limit.
Yes.
So what's the name of the comic?
The Crimson Duke.
The Crimson Duke. Okay.
So that's why there's a lot of blood.
Yeah, we'll be looking for it. Yes.
Yeah.
And well, the idea at the end was simple, to see what things you can actually generate with the model. But as you can imagine, by requiring 6 months, I had to do a lot of manual work. Because even a full regime, for example, for one day, you cannot generate properly more than 10 pages. Because it requires just too many generations to get the things you want. And the problem I was saying before, when you hit a road,
I don't know how you do it, because
patience and passion.
Because I use Copilot.
Okay.
To do just 1 or 2 images. Like, let's do a Christmas card. Sometimes that require at least 5 or 6 tries.
Right, exactly. Yeah. You've seen it. You want it perfect. You want it in a certain way.
And the problem is, for me at least, like with something like Microsoft Design, the problem is that, like, sometimes the one of the best alliterations, like the one that you like the best, are the one that there's certain things that I would like to change.
But they don't allow you.
They won't allow you. And then, for instance, especially if I use the prompt Chinese, let's say a Chinese lantern, what they would normally like to do is put some fake characters. Fake Chinese-looking characters.
In this case, basically, it's called prompt consistency. Those models that are not very good, or sometimes because of the scale, they're not very good models.
And I would be like, please don't put fake characters on that.
But also the interesting thing is that the technology to make all those changes is what I think was Banana Pro, right? Or Nano Banana. What the technology to, for example, make changes to an image already exists.
Yes.
And it's called, for example, image inpainting.
Yes.
When you want to basically modify using semantics, or image outpainting when you want to basically change the image outside the current one. So the problem is you basically rely on model creator or providers, and it's not usually convenient to even for example, I love it because I need to actually create those images for a practical purpose. But maybe we would not benefit a company to just add these unreliable feature, let's say, at scale. So, for example, even Midjourney, they have an option to make changes, but it's not very good. Maybe it's way better now, but they could improve it a lot. But there is so little demand that even if the technology exists, it's not added to those to
I would be
those
surprised
providers.
that there's little demands because I think, like really, sometimes it's just like very good images, except one corner is not doing well. This is very good images if it's a different lighting, but you won't be able to do that.
Well, how to say, probably is. I can imagine if the company don't want to implement it, maybe because it is a lot of trouble. For example, in Midjourney one, there are some images where this thing does not work and throws error. So I can imagine that. I mean, it's very problematic, or sometimes where it doesn't work at all. So because I think maybe it takes even too much computing power to make it. And so this perhaps is one of the reasons. But let's say there are, especially in image generation, I'm not a specialist there. I think you need to speak with a diffusion model specialist. But there are many, there are problems because the models are gigantic. Well, even LLMs, but LLMs, you basically have a range of models. They go from small language model, which we've been increasing a lot, to gigantic model. Image generation, the threshold to get a proper imaging is very high. And so even, for example, with Flux, which is one of the best, they start with model being, I think 12 to 24 gigabytes of RAM, VRAM, which is problematic for many users.
Well, Michelangiolo, you are just as brilliant as everyone promises. Like if Michelangiolo lives in the 20th century, probably be like you. Yeah. Thank you so much.
Thank you so much.
Grazie mille.
I wanted to leave one Easter egg. It's been a while since either of us have demoed. I think it would be great if we could collab and we would demo together. So an Easter egg for a future event, maybe not the mainline event, maybe we want to spend a little bit more time with the audience. We can collaborate and come up with something creative.
Sure.
Maybe with some comics or something. HP Lovecraftian horror comics and maybe some manhwa.
The Crimson Duke, yeah.
In the Great Wall.
Launch, yeah. So, well, like keep an eye on here. Keep an eye on the Hong Kong AI podcast.